Hi everyone, today I will present the paper Transforming Causal LLM into MLM Encoder for Detecting Social Media Manipulation in Telegram, in which we propose our solution for the shared task. This work was prepared by Anton Bazdarev and the team. So, disinformation on social media is a serious threat to public discourse and democracy. In Ukraine, where Telegram is a key news source, where rhetorical manipulation can easily shape opinions. That's why it's critical to accurately detect such techniques. The main metric for both shared tasks was F1 score, but at different levels. Macro average over classes for technique classification and char level for span identification. At the start, we used leaderboard probing to check class distribution in the public test set. Using the formula on the slide, we estimated class balances by submitting constants all ones prediction for each class. This showed the data split was like a multi-label stratified scaffold, so we use the same method for our validation. To handle class imbalance and improve F1 score, we explored several threshold optimization strategies as F1 maximizing grid search, where for each slide we searched for the probability threshold that gives the best F1 on validation. The next method is class balance regularization, where we are picking the threshold that makes predicted positive match the true class frequency for more stable results. Also, we use hybrid approach, where we average the F1 maximizing method and class balance method. And the last method we tried was Lipton method, but it underperformed compared to our main methods. In our final solution, we used F1 maximizing method for the span task and hybrid thresholding for the classification task. Moving to our experimental setup for the classification task. We tested several models like IXPANS, Llama 3, and Mistral Large, but Gamma 2 consistently outperformed the others, showing the best ability to handle language and domain-specific texts and capture subtle patterns. As a result, we selected Gamma 2 as the core model for our classification pipeline. Now let's move to results. In our experiments, Gamma 227B achieved a macro F1 of 0.5 locally and 0.46 on the public leaderboard. And also 0.48 on the private leaderboard, outperforming its smaller 9B parameter sibling in the new Gamma 3 model. Applying a 5-fold ensemble to the Gamma 2, the score increased to 0.47 and 0.49. So, moving to the span detection. Span detection as a sequence labeling task requires bidirectional context. However, we benchmarked two families of models. Encoder only, we tried MBERT, XLM Roberta, YevRobert, MDBERT v3, and AYA 101. Experimenting with decoder-only models, we tried Mistral, Phi4, Llama 3, Gamma 2, and Gamma 3, testing whether shear scale can offset unidirectionality. Let's move to the results. The best unidirectional model, Gamma 2 27B, scored 0.62 char F1 on our local validation and 0.61 on the public leaderboard. That nearly matched I0101 and MDBERT v3, showing that large causal LLM can already capture much of the needed context, but still lag slightly on precise span boundaries. Uh, as we saw on the previous slide, Gamma model showed slightly better span identification scores than the next best model, demonstrating its superior contextual understanding and language handling. We therefore decided to adopt Gamma 2 as the foundation for our bidirectional decoder. Firstly, we applied masked language modeling pre-training on domain-related Ukrainian and Russian news corpora to improve Gamma 2's bidirectional context modeling, resulting in our bGamma 2 encoder model. Next, we fine-tuned bGamma 2 on the shared tasks annotated spans. The results. Our bGamma 227B model achieved HRF1 of 0.64 publicly and privately, surpassing all encoder-only and unidirectional baselines by a large margin. Ensembling further boosted our performance, solidifying that bGamma 227B as the top choice for span detection. Besides our main models, we tried several alternative approaches, but none outperformed our core solution. Here is a quick overview. We tried translation-based methods, like translating posts to English for models like Llama 3 or Gamma 2. It didn't work well. Translation shift lowered performance. Zero-shot classification. We tried ChatGPT 4o in zero-shot mode, scored much lower than fine-tuned models. Also, we tried LADA model. This diffusion model underperformed compared to MDBERT and Gamma 2, likely due to weak pre-train. Two-stage pipeline. Running a classifier before span detection reduced false positives, but led to error propagation and lower scores. Also, we tried dual head models. Training both tasks together didn't beat our single task baseline due to task interference. Let's move to the conclusions. Gamma 2 competitiveness. A large causal LM can rival encoders. Yep. Hybrid thresholding. Research and class balance yields robust classification. Bidirectional pre-training. MLM conversion delivers state-of-the-art span detection. And dual task sort results. We set new competition bests on both subtasks. Private macro F1 of 0.48 score for technique classification and private char F1 of 0.64 for span identification. Thank you for your attention.